In our previous tutorial, we have seen how forward feature selection techniques work, and in this tutorial, we will take the same dataset but we will see how backward elimination method works. In backward elimination, we start with all the features and remove the significant feature at each iteration. We repeat this process until there is no improvement observed on removal of features. And before we start coding, I will show you how this technique works. Let's say we have 5 features in a data set. So these features are wine, malic acid, ash, magnesium, flavonoids, and this is our target variable. So in first iteration, it will take all these 5 features and fit our model, and it will check how much is the accuracy of our model. In the next iteration, it will take only 4 of these features and then again check the accuracy of the model. In the next iteration, it will take 3 features and check the accuracy of the model. In the next iteration, it will take only 2 features and check the accuracy of the model. In the next iteration, it will take only 1 feature and check the accuracy of the target variable. So this is the last model fitting step where it has only 1 feature. And now in the final iteration, it will tell us what are the best features for this data set, and it will tell the name of those best features. So here in this case, it is found that these 3 features, wine, ash and magnesium, are found to be the best features for predicting the target variable. So this is how the backward feature selection works. It will start with all the features, and in the next step it will drop one feature one by one till it reaches a stage where it sees that there is no improvement in the model even after dropping the features from the model. Now let's go to the Jupyter notebook and we will see it practically how it works. Let's import pandas as PD. Import pandas as PD from mlextend dot feature selection. So from this mlextend dot feature selection, we will import the class sequential feature selector, and this class will help us to do the backward elimination method. Now I'm going to read a CSV file and save in a data frame df. I will call here pd.read_csv, and inside this I will type the data frame name, which is wine.csv. and now let us look at the head of our data frame. So we have this top 5 rows of a data frame. So this is our data frame and all these are independent variable. In this data frame, the target variable is this variable, which is called here target. And now let us look at the shape of this data frame. So I will write here df.shape. So it says that there are 14 features and 178 rows. Out of 14 features, 1 is our target variable, which is this one, and 13 are independent variable. Now we want to fit the model, and before fitting the model, we want to check out of this 13 independent variables, how many of them are actually significant for our model development. And this we can find using the method backward elimination technique. Now let's do that. So first I will split this data set into x and y. So I will make here x, and then I will call df. From this I will call the method ILOC, and now I want all the rows, and I want column starting from 0 up to the column number 13 in x, and in y I just want a target variable. So I will write here df.ILOC all the rows and -1 to get the last feature. Now if I type here x.head, or let's say x.shape, so you will see here we have 13 features, and we want to determine out of these 13 features how many of them are actually significant for a target variable. So this we will find with the help of the backward elimination technique. Now I'm going to split this data set x and y into train, test and validation. So now let's do that. I will write for that. First I will import from scikit-learn dot model selection, import train, test, split. Now I'm going to make this variable xtrain, xtest, ytrain, ytest, and then I will call this class train test split, and inside this I will pass x and y, and I will pass the parameter test underscore size, which is 0.3. That is, I want 30% as testing data, and random state is equal to 1. If you want your result to be same as mine, then you also have to put random state is equal to 1. Now I will make an object backward feature selection or backward feature selector, and then I will call this class sequential features selector, and before this I have to call one algorithm. So on this data set we are going to fit the random forest classifier, so I will call that from scikit-learn.ensemble import random forest classifier, and inside this I will call this random forest classifier. I will type here, and inside this I will pass one parameter which is n jobs, and this is going to be -1. This means that how many cores you want to use, and I want to use all the cores which are available, so I'm typing here -1. And then we will start passing some parameter. The first parameter is k underscore features. So this parameter takes any number. So here let's say we want to say out of all the 13 features, I want to find top 8 features which are significant, so I will write here 8. The next method is forward, and this is going to be true because we are doing this forward elimination method. The next parameter is floating. We don't want to use this, that is why we will set it as false. The next parameter is verbose, and this is going to be 2 because we want to see how this model is fitting, so we will get the training data set. And the next parameter is scoring, so we will write here scoring. On what matrix we want to select these features, so we want to select on the basis of accuracy. And the next parameter is the cross validation, so we want to do 5-4 cross validation before selecting the top 8 features. And once we define all this parameter, then we will fit this on our xtrain and ytrain dataset. So I will write here xtrain underscore ytrain. Sorry, there is one mistake here. So here we have to set this as false because we are using the backward elimination method, so I will type it as false. If you are using the forward selection method, then you have to put it as true, but since we are using the backward elimination method, so we have to set it as false. Now I'll start running now it will start fitting, so you will see here we will get the output also. Now I'm going to check what are the significant features it found. I will call this backward feature selector. From this I will call k feature idx. So it says that these 8 features are significant, which is at this index number 0, 1, 2, 3, 4, 6, 9 and 11. And if you want to look at the actual names, we will write backward feature selector dot k underscore feature names. So these are the 8 features it found to be significant, and these are alcohol, malic acid, ash, alkalinity of ash, magnesium, flavonoids, color intensity, and this is the last variable it found to be significant. And to check the accuracy, we will call this backward feature selection dot k underscore score, and here you will see we are getting 99% accuracy, which is very high. So here you have seen that we have defined that we want 8 features, but now we will copy this code from here and I'll paste it here. And now I want to say that you take all the features from 1 to 13, and now you decide how many of the features are significant, and I'll run this code. So this time this method will give us the number of features it will find significant, not the number of features we want significant. So here we wanted 8 features, and this gave us the 8 features, and these are the 8 features. And now we have asked this backward elimination method to give whatever features you think are best for this model development. Now when this will stop running, this will tell us how many features it found to be significant for this model development activity. So let us also copy this code from here, and once it stops fitting the model, we will just paste that, and we will see how many features it is giving us. So it is still running here, and it will take another 1 minute, I guess. So you can see this we are seeing this is because of verbose. If you don't type here verbose is equal to 2, you won't be able to see this one. And for this, to see this only, we use this parameter verbose and we put the number as 2. So now it has stopped fitting. So now it has completed fitting, not stop. Now if I check the names, so now it says that these features are significant and these features are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it says that these 12 features are significant, and if I check the accuracy score, I will write here .k score. So I'm getting the accuracy of 99, 0.992, and here we were getting 0.991. So instead of these 8 features, if you use these 12 features, your accuracy will improve by 0.1, very slight improvement from 991. You are saying that it has gone up to 992. So it is okay even if you are using just 8 features, or if you just want a slight improvement, you can use these 12 features also. So it depends on you, but there is no significant improvement. There is just a digit improvement here. So this is how you can use the backward elimination method. And in a previous tutorial we have already seen how we can use the forward selection method. So these are the top 2 techniques which you can use before developing your model. So using this technique you will come to know which features are important, and you can directly use those features and get good results. This video was about backward elimination method. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.